the right on most servos. Some servos that's reversed, but it gives you an idea of where the servo would be. Okay, as usual, I hit C to begin my calibration. Okay, now those lights are also blinking just to show you that you're calibrating, but again, the frame rate's not fast enough to show you that. Okay, so what I'm going to do is I'm going to take my throttle, which is already calibrated, and run it through the range here. I'm going to have to set this down. Okay, but let me put this here so you can see the dot. And let me see if I can bring this in the frame too. Okay, whoa. Okay, so if I turn the throttle, this, whoops, it's going to roll. Hang on. There we go. Okay. So if I turn throttle to the left, then my servo goes to the right for right now. And if I turn it to the right, my throttle goes to the left. Okay. Now, that's not really important because you can reverse wires and stuff to change the direction of that. But let's just say for a minute that, maybe this right here is my maximum throttle position. All I'm going to do to tell the unit that is hit C. C sets the maximum throttle position while you're in servo calibration. Okay? Just one click takes it. Now, I'm going to move to this position here, and let's say that that is my minimum throttle position. Okay? And then to set the minimum throttle position, I hit D. Okay? Now, if I messed up and I needed to set it again, I can keep hitting B or C, and you can set those in any order that you want to until you have the maximum or full throttle position that you want set and the minimum throttle position that you want set. Those can be, even if the throttle, while you're calibrating it, doesn't make the servo move in the direction that you like, just note that as the throttle value increases, it'll build the calibration so that that will make the servo move from the minimum throttle position towards the maximum throttle position linearly. So that may reverse your throttle direction. So that might be useful if you need to reverse your throttle direction. Okay? So, and also, the note that I just made about reversing directions and all that stuff, if you don't even think about it and you just remember set the minimum throttle position, set the maximum throttle position, regardless of how you have to turn the throttle to get it there, 99% of the time it will work out on its own. You won't have to worry about it. So just a note. All right, so then what I'm going to do is hit A to store that calibration. You'll hear a beep again when it builds the calibration. Okay, so if you look here, now when I turn my potentiometer through the entire range, the servo only moves through the position that I set it for. So I'm turning it all the way from one end to another, and it's just moving from minimum to maximum. Also notice that in my case, remember how I was turning the pot to the left and the servo was going to the right? That's now changed. If I turn to the left, the servo also goes to the left. If I turn to the right, the servo also goes to the right. So again, I ignored which way the servo was actually moving in real life and just set it exactly like I want it. So I want the minimum here, I want the maximum there, and the system will figure out how to get that done. You don't need to worry about it. I've already figured that out for you. So, and that about does it for setting up your throttles and everything. So that process that normally takes a long time for people to do, the calibration of the throttle and the calibration of the servo, is done pretty quickly, thanks to this automatic calibration system. So, and I'm done calibrating the throttle, so I'm going to hit A to get out of there. Okay, let me think here. Is there anything else I need to say? Also, if you're interested, you can change a few things around on this board. One thing is that this board has a high and low battery alarm. You can read more about that in the directions that I've written. But if you don't like that alarm, or if you just don't like the thing beeping at all, you can take this jumper off right here, the one just to the right of the beeper there, and that'll disable the speaker. Just remember to keep that jumper safe in case you want to put it back later and turn the speaker back on. Okay, and then also, if you ever feel so inclined to see some output out of what this board is doing, you can. If you just take this jumper off right here, it's on the end on pin 7, pin set 7, and it's on the top 2 pins. I'm going to take that off there. Okay. Now, what I need to do now is I need to ground that pin. So normally it has a jumper on it that pulls that pin up to 5 volts, but if you want to use this data output feature, then you just ground the pin 7 again. I'm going to do that real quick. Hang on for a minute and bear with me. Okay. Okay. Whoop. Okay. Alright, so now it's grounded. Of course, almost everything takes a performance hit when you add a new feature on, so this will slow down the output rate of your servo a little bit, meaning that it'll not respond quite as fast to the throttle input as it normally does. But, I mean, you're probably only going to use this if you need to check something anyhow, if ever. You might not ever use it, but I thought I'd put it in there. Since it was useful for me, it might be useful to somebody else. Okay, so then now I have a serial cable hooked up from the unit to my laptop. That's not necessary for this to run, but it is necessary for you to see the data output if you wanted to. Okay, so I'm going to go over to a serial terminal here. I have it set up for 57.6 kilobits per second for the baud rate. That's the unit outputs. I have it for my COM port that I have the unit connected to. 8N1 is 8 data bits, no stop bits, no parity bits, and 1 stop bit. And then I have no flow control, and echo can be on or off. These settings may be arranged differently in your favorite terminal emulator. Okay, I'm going to hit connect. Okay, the unit will reset, by the way, when you do that, but anyhow, it comes back quickly. Now, what we're getting here is you'll see VN. VN reads the exact battery voltage to the 100th of a volt on the input of the unit. You'll see it's fluctuating here because I have this connected to a cheap wall wart, just a normal power supply like you plug into the wall for a phone or something like that. And then you'll see battery voltage listed there, T-RAW, STD. T-RAW is the input value that the unit sees from your throttle in RAW. STD is after it runs through the translation system that calibrates the data. And then S out there is the value that goes out to the servo. It'll vary from negative 1200 to 1200 depending on where you have the throttle set. Okay? Just something interesting to see if you ever want to play around with it or impress your friends or something like that. Oh, also a note. I didn't know if you want to use Futaba servos with this in the future, so I gave you a lot of range for where you can set the servo up. Some of the values that you can set the servo to are out of range for high-tech servos, but that'll be really obvious. Just while you're calibrating them, if you're trying to set it to a position and the servo starts shaking like crazy, well, not like crazy, but quite a bit, then you're probably either pushing into something or you're pushing against the mechanical limit inside the servo. So, just a note. I think that covers it. So, I'm going to leave that off there. And, yeah, just let me know if you have any further questions.